Now we're going to start getting into graphs. I think you probably did some graphing in Algebra 1, so maybe this first part will be a review, but I do want you to draw this graph and label all of the parts of this graph. And this is why we use them, because over here I wrote, since most of the relations that we will work with involve real numbers, these relations are infinite. I mean, there could be too numerous to count. All right, and they can't be indicated by listing like all of the ordered pairs. You just can't do it. But you can indicate these relations on a graph, because on a number line, each point corresponds to a number. Well, on a plane, like this one right here, each point corresponds to an ordered pair from the numbers r and r, where r equals the set of all real numbers. And this right here is called the the fancy word, a Cartesian coordinate system. Now, when you draw this, you've got an x-axis, which is going to indicate your domain of your ordered pair, the first set of numbers. The y-axis, which is going to indicate the range of your ordered pair, the second set of numbers. The x-axis is horizontal. All of these are horizontal lines, and the y-axis is vertical. They're divided, this coordinate system, this graph is divided into quadrants. Up here is your first quadrant. Using Roman numerals, this is your second quadrant. This is your third quadrant, and this is your fourth quadrant. The origin is where the domain and range both are 0. And we've got some points on here just to help you see. The domain of this point is 2, which is your x coordinate, and your y range coordinate is 3. And someone really smart said this to me one time. How do you know whether to move across or up and down? And they said this is a good way to remember. You have to run before you can jump. So you've got to run across either to the right if it's positive or to the left if it's negative before you can jump. And either you jump up or maybe you jump in a hole, I guess, if you're going to go down. So that's a good way to think of it. Your this point was 2, 3. So if we run over here, -3, and jump up 1, this is our coordinate, -3, 1. If we run to the left, only 1.5, which is -1.5, and fall in a hole, -2.5, that's where this coordinate would be found. So hopefully this is a little bit of a review for you when we get into graphing. Now, we may be asked to graph equations. So this is how it's going to go. If an equation has two variables, its solutions are ordered pairs of numbers. That means we need a solution for the x, and a solution for and something for the y, where they need to go with each other. A solution is an ordered pair such that when the numbers are substituted for the variables, a true equation is produced. Determine whether the given ordered pairs are solutions for this equation. So I've given you an equation right here. Well, we can't see it all. Here's the equation, y equals 3x minus 1. And you're asked if -1 and -4 are solutions, and if 7 and 5 are solutions. And we know the domain is our x value, and the range is our y value. So the first one I did was I put in -1 and 4 into this equation. So I wrote it like this to help us see if this is going to work. So -4, that's our y, equals 3 times -1, that's our x, minus 1. And when I worked all that out, I got it to equal -4 does equal -4. So -1, -4 is a solution for this equation. Well is 7, 5. So over here, I did the same thing. I wrote it out to see if 7, 5 is a solution. So y is my range. So 5 equals 3 times 7 is my domain, my x. So I put it in here. Minus 1. 3 times 7 minus 1. And when I work that out, I've got 5 equals 20. Well, that's not right. So 7, 5 is not a solution to this equation. Down here, I'm going to graph a really pretty equation. This is y equals 3x plus 1. The solutions of an equation with two variables are ordered pairs and thus determine a relation. And what we're going to do is we're going to record these ordered pairs in a table, kind of like I put right here, and plot the points. If we could plot all the points, they would form a line. Now this particular equation has an infinite set of solutions because it says y equals this. So whatever we put in for x, we're going to get a y for it. And since it does, the graph of the equation is drawing the solution set. So I put a few numbers in here to get us started on our graph. First I put in 0. And when I put 0 into this equation for x, y equals 1. So I'm going to plot that. 0, I'm going to run over 0, so I'm not running at all. I'm going to jump up 1. So there's my first point. When I put 1 in for x, right here, I get 4 as my y. So when I plot this point, these points right here, I'm going to run over 1 and jump up 4. Now I'm going to show you what it would be for -1 because it's an infinite number. I could use any number in here at all. So if I put -1 in for x right here, that's -3. -3 plus 1 is -2. So I'm going to run to the left 1 because it's negative and fall on a hole 2, -2. So that would be my point right there. If I put in -2, same thing. Up here, I'm going to get -5. So I'm going to run over -2 and fall down in a big hole, -5. And all I have to do is use a ruler and draw a line and show my arrows use my arrows to show that there's an infinite number of solutions for this equation. And that's what it would look like on the graph. Here's another interesting one. You're asked to graph y equals x squared minus 5. So I'm going to do the same thing for this one. This one has infinite number of solutions because it's y over here, and whatever I put in for x is going to give me a y. And when I do that, I'm not going to talk you through all of these. This is what my graph would look like. And so this is the graph of the equation y equals x squared minus 5. All I did was put in my x. I just picked a number. Start out with simple ones because that's where my graph is. My graph is not showing too many numbers, so I can't get too high. But it shows you the general direction of what it's going to go. It's just going to keep on going up this way and keep going on up that way. Because when you square a negative, it becomes a positive, right? So, wait a second. It's going to start becoming over here. It's going to start becoming positive when it gets bigger because I'm only taking away 5. But yes, what I said was true. I confused myself for just a second there. But anyway, that's why my graph looks like it's in this kind of like a U-ish, V-ish shape. Eventually, these numbers are just going to keep going way up here. All right, we're going to be doing more work like this soon, so I hope this helps you out. Thank you very much.